going on, dudes? I want to walk you through one of the assignments I just created. Instead of typing up all these instructions, I figured I'd record a video. Sometimes those are easier to understand. It's called Periodic Scaling Data, and it is an idea that I had based off of the Straws lab that we did this past Wednesday. And I thought, man, that thing is tedious. Let's see. Here it is. Let's just remove this altogether. Alright. This is the one. So, check this out. We have a 3D printer. That is amazing. And what I've figured what we could do is I want to use it for chemistry. And so I kind of gave you an introductory assignment. Let me show you that introductory assignment real quick. It's this homework 3D printer Tinkercad. I basically want you to create something for me in Tinkercad and learn all of the background things, because we're going to use this Tinkercad for the 3D printer when we eventually get there, and I want you folks to get good at it. Also, I'm going to have you use it for this lab. So what you want to do is you want to open up this 3D periodic table that I made. This thing took me a while, but I think it's cool. Just click this Edit in 3D button, and hopefully that brings you down to the right spot. Actually, you know what? Let me open that up in a new tab, because... Alright, here we go. I'm just going to press Control, open... Oh, there's no open in 3D. Alright. I know what I'll do, is I'll just... There we go. This is the periodic table. And I think that this will work where you folks can start editing it. What I would rather you do, yeah, why don't we have everybody do this? Don't edit this thing right here, because I'm not sure if that edits the master file, and I don't want everyone to edit this, template file. So make a copy of it. Alright. If you want to rename it, you should probably... Actually, I'll show you how to rename it in just a second. What we're going to do is we're going to scale this periodic table. And we're going to make this thing into 3 dimensions. What I mean by that is that there are some trends in this periodic table that, to be honest with you, I don't think we even have the charts for. So what we're doing in this lab is we're actually creating some original things, because I'm not sure if anyone else has the capability to do this, or not necessarily the capability, but has done an assignment like this. So it's pretty cool. I'm excited about it. Alright, come on. Finish uploading. There we go. Almost there. What about that one? There we go. Okay. So here's what I want to do. Is I want to scale the height of these blocks to match the data that I'm looking at. And the 3D data that I want to find, you can click here and it will open up this file, which is the same as that file. And here's the data for the periodic table. So here's all the elements and the group, and I just took all of this data and put it up online. Here's the data, here's the group number, the period, here's the name in English, this is the name in German. Well, I'm curious to know if gold is known as Arium. Oh. I guess no one calls it Arium anymore. Huh. Alright. Well, here's the English name and the German name and the French name and the Spanish name and the Italian name. Wow. The Italians don't call hydrogen... What? I've never heard Germans call it Wasserstoff. Anyway. And I have a lot of the data, like the atomic mass, the melting point, the boiling points, all of this kind of stuff. And so what I want to do is I want to take this data and scale it into a 3D model. And the way I'm going to do that is I made this table for you. So, for example, if your job is to do the ionization energy, this would be this. Here's the full ionization data And what I want to do is I want to scale that to be the maximum height of 50 millimeters. So what I did was I just said, okay, I found the biggest value in this list, which apparently is 24. And I said that value is my 50 milliliters. And so what I want the computer to do is scale everything accordingly. So like 21 would become 43 millimeters, and so on and so forth. Now what I want you to do is I want you to take this data and use it to represent the height as to which this table is set at, or the elements of this table. So for example, the scaled ionization energy is 27.7 for hydrogen. So all you do is you go to hydrogen and you set the height of this thing to 27.7. So right now it's 10. So 27. Oh. I guess I can't get the. Oh, wait. I know why. $27.7. Awesome. Then what I'm going to do is I'm going to move this thing. Oh, oops. Not that way. Oh, I'm going to click on this thing, and I'm going to get this arrow, and I'm going to move him down to be at. I guess that would do. I want him down a little bit more. Let's see. I wonder if I can type in this. Adjust. No, I can't. Never mind. Alright. 27. Alright, that will work. I'll just move it down. So she sits right flat on top there. Okay, cool. Alright, I'm done with hydrogen. Alright, let's go over to helium, 50. Alright. So helium's at 50. So you click here. And if you want to raise the whole box up, you would use this arrow. But if you want to scale the height, you'd use this arrow. And so you go down to up to 50. So here's 50. I'll tell you what. Let's make a deal. It's tough to get this thing precise. I'll let you be as precise as you want. Try to get it within reason, though. I'm going to move that thing down to be about 50. Alright, cool. Let's see. Let's move them down just a little bit more. Alright, and you know what I'm deciding is move the tile to be just below. Like if you can't get it to be exact, you want it to maybe be a little bit below. So that way it's connected. You don't want this tile to be floating off the thing. Because if we were to 3D print it, then this thing would print it up as separate. Alright, so what else do we got to do? We got to do ionization energy. Then we just go down this line. So lithium is 11. So here's lithium. Move him to 11. Oh, that's pretty easy because he's at 10. That's close enough. Yep, and then you basically just do the entire periodic table. So I don't want everyone doing the same exact one. Oh, by the way, if there's a blank, just move the height down to 0. So let's see. Also, I don't include the lanthanides and whatnot on the bottom part of the table. Notice how my periodic table is kind of missing that bottom part. I'd like to skip that for now. I just want to see this part for now. Let's see. Let's see. BH is BH something. Where's my BH? Oh, yeah. So BH has a 0 next to it. It's because I don't think that we figured out the ionization energy for this particular element yet. So why don't we just leave anything that has 0 at 0? So BH, I think that would be this guy. Nope, it's this guy. I'm going to drop him down to 0. In fact, why don't we say this? Just delete him. And then we'll take the tile and put it down at 0. There we go. Perfect. And that's your project. You basically have to go in and finish the rest of the periodic table. Boom, boom, boom. So I don't want everyone doing the same data, so what I decided to do was I broke up the data into particular groups. So here's your name. Here's the project I want you to work on. Now remember, make sure that you use the scaled data. So I have the AMUs over here. This is the atomic mass unit, or the atomic mass. Here's your scaled version, and this is the one. These are the numbers I want you to follow. So here's the density. Here's the actual density. Here's the scaled version of that. So that's the numbers I want you to input on this thing. Now, what are you going to do? You are going to save this project, and so let's go around about doing that. To save the project, maybe what I want you to do is do this. I want you to go to Design, Properties, and let's call it, let's call this thing and then put your name. Let's make it a, so there we go. Dalde, comma. Alright. And you can make this public or private. Actually, make it public. I don't mind if everyone sees this thing. Hopefully you don't mind either. And then what I want you to do is download it for 3D printing. I want you to download an STL file. And then I want you to upload that STL file to this assignment. So let me re-edit this assignment and give you folks editing capabilities. Or not edit, submission capabilities. Let's see. This would be enough points. I'm going to make this thing a whopping 40 points. And I want file uploads. You could even give me website URLs. Cool. This is not a group assignment. Why don't we make this due on the 3rd? And yeah, that'll be good. You know what? I really want you to turn it in by the 3rd, so I'm going to close it pretty quickly after that too. Alright. So that's your assignment. Hopefully it makes sense to you. Let me know if you have any questions or if I missed anything.